we have seen in yesterday's discussion having one primary coil and two secondary windings. So this is another maybe inner details of your LVDT. This magnetic core is actually free to move to and fro, as well as this can be rotated. And if you move this particular core more towards S1, EMF induced in S1 is going to be more, and EMF induced in S2 is going to be less. If you move this particular core more towards S2, then EMF induced in S2 will be more when compared to the S1. So those informations have been kept in written format. And of course, if you keep the core centrally located between the S1 and S2 secondary windings, then there will be zero output. Because in both S1 and S2, EMFs that are going to be induced are going to be equal and opposite. So because of that reason, they are going to balance together and there will be no deflection. So whichever the side it is going to show more inclination, that side more EMF will be there. On the other side, less EMF is going to be there. Because of that, the difference is going to give you the voltage. And moreover, on its usage, even if you keep the core in the central position, exactly, it is supposed to show zero displacement, but because of the presence of residual current, so what it will try to do is, it will not show zero, it will show some other than zero. In the actual situations, we try to adjust that by adjusting the gain. Anyway, so this is going to quantify the minimum amount of displacements what can be measured using this. So 0.0002. And of course, core mass, if you try to refer, when compared to the strain gauge, that is not going to be easy. Because of that, it is actually having a higher amount of mass. 1 second. So if you try to see this, the core weight is actually more. So when compared to the strain gauge, because of that, it may not be possible for us to go ahead with dynamic measurements. Okay. So that is one major thing what you should. Anyway, if you have some parameter like pressure, acceleration, vibration, force, and liquid, all those things, and if you can somehow can convert them into displacement, all such sorts of things can be measured under this. That is the major advantage over here. Okay. Then something like that with respect to the resolvers will be giving us a scope to measure this particular theta angle. See, I've got a shaft on which primary windings are there and two mutually perpendicular shafts are there on which maybe this is one secondary winding, this is another secondary winding, this is cos and this is actually sine. If you try to measure the value through cos winding, say if you know this particular theta and further if you obtain cos theta, that value will be equal to the value whatever you are going to read from the secondary winding. Same is the situation even over here. If you have an idea on this particular theta, if you calculate sine theta for that, from this winding, if you try to measure, that value will be equal to sine theta. That is the reason why for this particular coil, it has the windings, it has been stated as cos, and for this set, it has been stated as sine. Now, this particular technique has been used to obtain theta like this. Say for example, you doesn't know any value of this particular theta. Randomly, if it has been rotated. Now the value whatever you get from here, that is nothing but cos of this angle, cos theta. Now from here, if you measure some value over here, that is nothing but whatever the angle over here, that angle being applied with sine of that particular angle. For this, cos of that particular angle. Having an idea with this particular value, from here, we can equate that, say, cos of that angle equal to x and angle equal to cos inverse x. Similarly, over here, sine of that angle equal to y, then angle equal to sine inverse y. So now, since we have tried to check with the known value of theta for the obtained values of sine and cos from these two windings, it has been proved that the value whatever you are going to get here, that is equal to cos of theta. Whatever the value you are going to get here is actually sine theta. Now, even if you doesn't know the value of this, since you know that the value whatever you are going to get here, since you know that whatever the value you are going to get here is actually sine of that angle, it is possible for us to estimate that. Same is the story even over here. Whatever the value you are going to get here, that is cos of that angle, because of that, cos of that angle equal to some x, because of that angle equal to cos inverse x. Anyway, looking at the the advantage in having this kind of sensor resolvers, it has been found that it has been put in use for robo brushless motor controllers. Anyway, resolvers is an analog position sensor that is absolute over a sine turn. A resolver will be having a rotary transformer. Whatever we have seen in the last slide, same information has been. See, you have got a rotary transformer. That kind of description has been made to pass through. We also came to know that these two things are actually making 90 degrees. That has been stated over here. Okay. So now this is actually having some reference winding. That is what has been stated here. Okay. Since there are no brushes that are all maintaining the contact with commutator light, there is no wear of those brushes. Because of that, lifespan is actually more, as well as the reliability with respect to that is also more. Anyway, if I want to know the absolute position, since you know sin theta and cos theta, if I try to take one over the other, I will be able to get tan theta. That will be giving me the position of it. Now, in the last statement, it has been stated that even if you remove the power supply, there may be some rotation, or the rotor will might occupy new position. Your resolver will be giving the values. The resolver will be giving the new value the moment the power has been restored. That is the advantage in this. Then coming to the velocity sensor, velocity or speed sensor is trying to measure consecutive or successive position measurements at known intervals and also calculates the time rate of change in the position values. It is something like when you are asked to calculate velocity, what we try to do is we try to take positions, say x1, x2, x3, x4, and the time it has taken to move from x1 to x2 is going to be recorded. Likewise, from x2 to x3, x3 to x4 and all. So once you know the difference between two positions as well as the time it has taken to move from position 1 to position 2, one over the other, dx by dt, if you try to put, you will get the velocity. And that again, if you try to differentiate with respect to time, you will get acceleration. So same information has been recorded over here. And of course, in order to read the velocities, you have got tachometers and of course LSVs, laser surface velocity meters. Okay. What exactly the tachometer is trying to do? It is an instrument that has been used to measure the rotational speed or the angular velocity. Maybe I will try to show you one tachometer. This is actually analog tachometer. This is not working. This is actually British make. It has served its service for more than 30 years in our institute. This we use it in our laboratory. What we try to do is, wherever the rotational shaft is there, there is going to be a tip, and that particular tip will be attached to that, so that this particular shaft will be rotating. When this shaft rotates, there is a needle. That needle also moves. Say you have inserted and this particular needle is moving. When you want to record the value, what we need to do is, there is a lock. There is a lock. So ensure that that is actually going to position, and then lock it, then remove it, so that you can read this particular value. The moment you unlock, that will go back to its position. Okay, so this is actually analog tachometer, and you have got digital tachometer, wherein you have got memory. So some values of it being read. Working principle is the same. See, this is the knob. What we will insert exactly at the center of the rotational shaft. Say shaft might be rotating, there will be some small hole would have been made, and in that particular tapered hole, we try to insert this particular tip. The moment it has maintained the contact, it will start rotating. Once it starts rotating, then the corresponding value will be displayed here in terms of RPM value, revolutions per minute value, or meters per minute value. These two values will be displayed here. And if you press this button, that value will be stored. That value will be stored. So this is analog meter, tachometer. This is digital tachometer. So both are contact type. So you have to maintain contact with the shaft for which you are trying to measure the speed or the rotation. Okay, rotational speed. Okay, so what has been stated over here is, same thing can also be used to measure flow of liquid. So it is something like this. Suppose there is a canal through which water is flowing. You try to mount a wheel having some vanes, which can be maybe with the flow of water moving over the vanes, that wheel will be rotating. Once the wheel starts rotating, what can be done is, exactly at the center of that, we can insert and we can see the RPM of it. So that is how even the flow measurement also can be achieved with the support of tachometers. That's what that has been. Of course, you would have seen rotameters for the measurement of fluid flow or even gaseous flows. If you try to, many such types of setups are there in our laboratory. Anyway, tachometers are basically being classified on three grounds. One is based on the data acquisition, that is contact type or non-contact type. That means this is actually contact type. Unless otherwise you bring contact to the shaft, that is not possible. There is another one, non-contact type. This is that. We will not have anything like that. This is not working. If I put it on, once I push it on, then there will be one light that is going to be emitted from here. That light is going to be made impinged on the shaft, which is rotating. On that, one reflector sticker is going to be kept over there. So that beam, whenever it has been made impinged on that reflector, from the reflector it reflects back. You should ensure that that is going to enter through this. There is a photo receiver again in this that senses that the frequency with which that has been sensed. Based on that, it is going to show again in the display. It is going to show again the speed with which RPM with which that shaft is rotating. So first category is data acquisition, that is based on contact type or non-contact type. Second one is measurement technique. that might be measuring the velocities, maybe based on time or maybe based on frequency. And of course, third variety is actually analog type and digital type. This is analog, this is digital. So under digital, you can have contact and non-contact. If you happen to visit any of the pretty good service centers, they will not even use laser type, non-contact. Sound type sensors are there, wherein looking at the engine sound itself. So when the engine is running, then that sensor will be brought close to that particular engine. It is going to sense the vibration of the engine, and that itself is going to give a measure for RPM. That is another type. Okay. So vibration sensor it is. Based on the vibration being sensed with that, it is capable to give the RPM. So normally engine tuning is being done at the service centers, not in the small service centers, only in big service centers. Okay. So such a kind of device is going to be put in use. What is happening altogether? It is trying to provide rather the relative motion between the magnetic field and the shaft. So it is actually taking into account the relative motion between the magnetic field and the shaft, and that relative motion is going to induce EMF in the coil that has been placed with the support of permanent magnet. So indirectly, he is trying to give us a hint that they are trying to employ permanent magnets in these type of LVDTs, tachometers. Okay, so tachometers will be making use of permanent magnets. Okay, so now the relative motion between the magnetic field and the shaft is going to induce EMF, and that EMF is going to be induced in a coil that has been placed in the magnetic field of the permanent magnet. Now that EMF that has been induced is directly proportional to the shaft speed. That is directly proportional to the shaft speed. More and higher is the shaft speed, more is going to be the EMF. Lower the shaft speed, lower is going to be the EMF that has been induced. Anyway, in the analog type, you have got a needle. This is what is this needle and dial. No provision for storage of readings. This has got no scope to memorize the readings, and this cannot be interfaced to the computers. Okay, so because of that, since this is not having any memory, that value, that data cannot be read and processed further. That is the reason why it has been stated that it is not possible for us to calculate the averages as well as the deviations. As well, there is no interface to the computer. The data cannot be directly fed to the computer. Whereas with respect to the digital tachometer, the display is going to be either LCD or LED type, and there is a provision for storing the value in the memory. Once you are capable to store the data in the memory, it is possible for us to perform statistical operations like averaging, deviations, all those things are possible. Moreover, it is quite possible to interface to the computer so that straight away that value can be interfaced, read by the computer. And of course, contact type and non-contact type, we have seen the wheel of the tachometer. This is the wheel of the tachometer is going to be maintain contact with the rotating object. Then coming to the non-contact type, there will be no contact. That is what is one variety is actually this type. There is no wheel. Whereas when you press the button, there will be one light that is going to be emerged out. That will be ensured that is going to fall on the reflector. So reflector on the shaft will also be rotating. Instantaneously, when the light falls on the reflector, that reflects back, and you are supposed to ensure that is going to pass through this. So non-contact type will not maintain contact. time measurement. Speed is going to be calculated with the support of time interval between the incoming pulses. With respect to the frequency, tachometer calculates the speed taking into account the frequency of the incoming pulses. Now if I try to see this particular diagram, this is a block diagram for a digital tachometer. You have got a sensor that may be optical type or magnetic type. You have got signal conditioning, and there is a microcontroller to process the information. So the processed information is going to be sent to the memory, as well as it is going to be displayed, as well as that is going to be sent to the controller. Means if you want to regulate the speed, okay, you need some controlling, you need to take the support of some controller. So this particular microcontroller will try to send the information to that particular controller also with the support of some external port. Maybe through the same port, if you want, they can interface it to the system, wherein that is again going to further process the information, and it is again going to send the feedback signal back. Okay. So in a digital tachometer, these are all the what you call things that are all happening at different stages. With respect to the analog tachometer, no doubt we all have seen that the vehicle speed, whatever has been displayed in the support of a needle, all that are all analog tachometers. There the interface is actually dial arrangement and needle. In these situations, what is actually happening? Speed is normally converted to voltage. For that purpose, they are trying to take the support of external frequency to voltage converter. Okay, frequency to voltage converter method has been adopted in the analog tachometers. Because of that reason, looking at this frequency to voltage converter, looking at this particular statement itself, we may get a query that can the tachometer act as a generator? Yes, the tachometer also can act as a generator, and that can produce certain voltage, that too proportional to the speed of the shaft. Then the voltage can be displayed by an analog voltmeter. So it is also possible to display that value. Then coming to the laser surface velocity meter, LSV, laser surface velocity meter. This is actually non-contact optical speed sensor. This is non-contact optical speed sensor. What all it measures? It is trying to measure the velocity and also the length of the surface what is moving. So for example, imagine this itself as a surface. This surface might be moving. Your sensor will be here. Object is moving. Because of that, it is going to sense the object at the starting point and the end point. Time it has started sensing the starting point, and the time it is going to stop the sensing the end of that, is going to give a scope for that to measure length of it also. So this LSV gives us a scope to measure the speed as well as the length of the moving surface or object. How that is working? That is working on the principle of Doppler. That is Doppler effect. What it is trying to do, you can see here. You have got a particle that is moving. Okay, some laser has been made impinged on that particle, and if I have the particle is moving with a velocity v in this direction, then the laser whatever has been made impinged on this is going to be reflected in a direction such that this direction is going to be perpendicular to the particle moving velocity direction. We are going to arrange one detector inline to this. Okay, then we'll be able to sense that particular pulse. Okay, so that is how we are trying to catch up the pulse of it. Okay. Anyway, that is how the information we are trying to sense over here. But altogether, what it is trying to do is, as a matter of Doppler effect, there is going to be change in frequency of wave for an observer moving relative to the surface. Suppose you have a surface here, you have an observer here. This observer may be emitting light. When the observer is stationary, and if the object is also, maybe obstruction is also stationary, when you try to emit the light, the frequency with which it has emitted, with the same frequency it is going to return back. Whereas if you try to move the observer close to the, nearer to the obstruction, then what happens is we will find some change in the wave frequency. Same is true even if you try to move the observer away from the obstruction. Okay, so that is the principle on which the laser surface velocity meter is trying to work. Now let us go to